A very good afternoon to all of you. Today I would like to talk about some important optical properties of mineral like twinkling, birefringence, isotropic and anisotropic minerals. So let's start with isotropic minerals. So isotropic minerals, they belongs to the cubic system or isometric system, in which light travels with the same velocity in all the possible directions. And each mineral has only one refractive index. And these minerals don't show double refraction or birefringes. So for instance, non-crystalline substances, opal and glasses are also isotropic. Now diamond, garnet, halite, galena are some more important isotropic minerals. So optically isotropic substance such as gases, liquid, glasses and highly symmetrical cubic minerals, they show optical behavior that is independent of the direction of light propagations. So this means their optical properties are identical in all directions. So in PPL, that is pane polarized light, isotropic minerals show the same color independent of orientation and rotation of the stage. For example, garnet. And in cross-Nicol, that is cross-polarized light, isotropic minerals appear black independent of orientation of the stage. So this is isotropic minerals. Now anisotropic minerals. So anisotropic group include all the crystals except those of cubic system, in which velocity of light varies in different directions and the Ri, that is refractive index, also varies consequently with crystallographic directions. So these minerals show double refraction. Quartz, gypsum, calcite, fluorite, tourmaline, topaz, they are anisotropic minerals. So light propagation in optically anisotropic mineral is direction dependent. So all non-cubic crystalline substances are optically anisotropic, and light entering an anisotropic crystal is split into two light waves, that is E rays or extraordinary rays and O rays, that is ordinary ray, except optical axis. So two waves propagate through the crystals with different velocities. So anisotropic minerals show color variations according to the orientation of light passing through crystals. So this is all about isotropic and anisotropic minerals. Now I will take another optical property, that is twinkling. So let's start with twinkling. So the phenomenon of twinkling is well seen in calcite, and the change in the relief observed when the microscopic stage is rotated, then the twinkling effect is seen. The reason for this is the variation of the refractive index of mineral. with the direction observed. Only certain minerals exhibit twinkling, that is in calcite. How? So in calcite, the refractive index of the ordinary ray is 1.66 and for the extraordinary ray is 1.49 and the refractive index of the Canada balsam is 1.54. So if a granular mosaic of calcite is examined in polarized light, some of the grains will reflect ordinary light and other reflect extraordinary light. So those grains transmitting the ordinary ray have Ri much greater than balsam and therefore their borders will well marked, while those grains transmitting extraordinary ray have Ri lower than that of balsam. So their borders are not strongly marked, and when the polarizer is rotated, alternately strongly and slightly marked borders are noticed, showing twinkling effect. So this is all about twinkling. Now I will take another topic, that is birefringence, or you can say double refraction. So it is defined as the maximum difference between the refractive indices exhibited by the material. So optically anisotropic materials or minerals are said to be birefractive. So more simply, when a ray of light falls upon a birefractive minerals, it is split into two rays, that is slow and faster. Slow ordinary ray and faster is extraordinary ray. So for slow ray it is high refractive index. The ordinary ray travels with the same velocity in all the direction through the crystals, and this ray will therefore have a constant Ri, and in extraordinary ray the velocity of the ray change with the vibration of its path through the crystals, and its Ri also changes. So therefore the difference between the refractive indices of the ordinary ray and extraordinary ray is called birefringes. And for biaxial crystals, the numeric difference between the greater and least refractive indices is the birefringes. So you can say birefringes indicates the degree of double refraction in a substance. So these are some important optical properties of minerals. Tomorrow I will discuss another optical properties. Thank you students. Good day.